Swayam Prabha. Digital India. Educated India.
Now let us go to next problem. A continuous random variable x that can assume the value between x equal to 2 and x equal to 5 as the density function given by f of x equal to k into 1 plus x. Find the probability of x is less than 4. By property of probability density function, we have integral f of x dx equal to 1. Now we have values between 1, 2 and 5. Therefore, lower limit is 2 and upper limit is 5, and f of x is k into 1 plus x dx. So, we have what the integration is k integral dx plus integral x dx, which is equal to k into x plus x square by 2, and over the limit is 2 to 5. So, we have what this equal to 1 and k into 5 plus 25 by 2 minus k into 2 plus 2 square by 2 which is equal to 1. Therefore, we have the net value is equal to 27 by 2 into k equal to 1. This implies k equal to 2 by 27. So, this way we can deduct the value of k. Now, you know p of x is less than 4, which is equal to probability of the x lies between 2 to 4, and the corresponding integral is 2 into 4, 2 to 4 k into 1 plus x dx equal to 16 by 27. You know the k value. So, we have substitute the k and get the answer. Next question. Continuous random variable as the PDF f of x equal to k into x square e power minus x, where x is positive. Find k, mean and variance. So, by properties of probability density function, we have integral 0 to infinity k into x square e power minus x dx, and k keep as it is, and x square e power minus k x dx, we have the value of the integral is 2k equal to 1, where k equal to half. So, according to the mean definition, e of x equal to integral x into f of x, and variance of x is defined by e of x square minus e of x the whole square. So, e of x square equal to integral x square into f of x dx. So, e of x equal to half into k is half, and integral 0 to infinity x cube into e power minus x into dx. Now, we have to apply with integration by parts. This is also integration by parts, so that x cube keep as it is, integrate e power minus x is minus e power minus x, minus x square, x cube is differentiate 3x square, e power minus x is integrate is minus e power minus x, minus minus plus, and 3x square integrated 6x, and e power minus x integrated minus e power x, and 6x differentiation is 6, and e power minus x is minus e power plus e power x. Now, apply the limit 0 to infinity. So, first part will be 0, second part when infinity applies 0, 0, 0. For lower case it is 0, second term 0, third term 0, and last term we have plus 6 by 2 is 3. So, that is the way we can expect e of x equal to 3. So, e of x square equal to half into integral 0 to infinity x power 4 into e power minus x dx. Once again integration by parts u dv, and keep x power 4 as it is, integrate e power minus x is minus e power minus x, and x power 4 integrate it minus 4x cube into differentiation of e power minus x, and 4x cube differentiation is 12x square, and corresponding e power minus x. 12x square is minus 24x into e power minus x, and x differentiation is 24 into e power minus x, then the limit 0 to infinity. So, the value is 12, therefore, a variance of x equal to e of x square minus e of x of whole square equal to 3. And next example, the probability that a person will die in the time interval t1 t2 is given by probability of t1 less than or equal to t less than or equal to t2 in the interval t1 to t2 a of t dt. So, this one is already we discussed in mortality of the functions. So, refer it. And next 13th, a continuous random variable as a PDF f of x equal to 3x square, where x varies from 0 to 1. Find a and b such that p of x less than or equal to a equal to p of x greater than a, and p of x greater than b equal to 0.05. Now, the solution is probability of x is less than or equal to a equal to probability of x greater than a. So, we have the integral 0 to a 3x square dx equal to integral a to 1 3x square dx. Now, because y a to 0 mean lower limit a, upper limit is 1, and here the lower limit 0, upper limit is a, because x is less than or equal to a, function is 3x square, and 3x square integrate is 3x cube by 3, and then 3 get x cube, upper limit what a cube, and lower limit 0, for this is here, and for this one 3x cube by 3 over the limit a to 1. So, 1 minus and lower limit a cube will come. So, this is the this case, this is the this case, and then here minus a cube bring this one is 2a cube equal to 1, implies a cube equal to 1 by 2, right, and a equal to cube root of 1 by root 2, 1 by 2 whole power 1 by 3. So, this is the value of 0.7937, and if probability of x is greater than b is equal to 0.05, and we know the definition integral b to 1 3x square dx equal to 0.05. Therefore, and expand it 3x cube by 3 over the limit b to 1. Therefore, what 1 minus b cube, right, upper limit is 1 and lower limit is b cube, right. So, the value is taken positive and this value equal to 0.05, therefore, b cube equal to what 95. So, b equal to 0.9830. Once again, let us start with example 14. So, the distribution function of a random variable x is given by f of x equal to 1 minus of 1 plus x e power minus x. When x is positive, find the density function mean variance of x. So, according to the property of f of x, the probability density function f of x is given by small f of x is f dash of x at the point of the continuity of f of x. Given CDF is a continuous for x is positive. So, f of x equal to 1 plus x into e power minus x minus e power minus x, and simplify equal to x into e power minus x. So, e of x equal to integral 0 to infinity, we have x square into e power minus x dx, right. So, that becomes what? Integration by parts, do that, and finally you substitute the value is equal to 2, and e of x square is equal to integral 0 to infinity x cube e power minus x dx. Once again integration by parts, you do that, we have 6. So, the already explained the x square into what, e power minus x minus 2x into e power minus x plus what, 2 into minus e power minus x, then over the limit 0 to infinity. So, the net value is 2. If you go x cube, then it becomes x cube into minus e power minus x minus 3 into x square into e power minus x, and then next one is plus 6x into minus e power minus x, and next one is minus 6 into e power minus x, and then 0 to infinity, the value is 6 will come. Once you got 2, substitute here, here substitute, and here this value substitute here. Therefore, it becomes 6 minus 2 square equal to 6 minus 4 equal to 2. So, this is the way we can calculate what? Variance. Now, next example, in the CDF of the continuous random variable x is given by f of x equal to 0 when x is less than 0, x square 0 less than or equal to x less than half, and then 1 minus 3 by 25 into 3 minus x of whole square when half greater than or equal to x less than 3, if it is 1 x greater than or equal to 3. So, find the PDF of x, evaluate probability of modulus of x less than or equal to 1 and the probability of 1 by 3 less than or equal to x less than 4 using both the PDF and CDF. Now, we have a solution. X equal to 0 of 3 are the points of continuity, so that f of x equal to, the value will come when x is less than 0, 0, simply differentiate x square 2x in the interval 0 to x less than half, and then 1 minus 3 by 25 into 3 minus x square, differentiate it, 1 differentiate 0, and 3 by 25 into 3 minus x whole square, differentiate 2 into 3 minus x, and it becomes 6 by 25 into 3 minus x, and last case 1 differentiation, it becomes 0. Therefore, the value 0 corresponding x is greater than or equal to 3. So, the point x equal to half 3 are the points of discontinuity of f of x. So, we have f of half equal to 3 by 5 and f of 3 equal to 0. Therefore, probability of modulus of x less than or equal to 1 equal to probability of minus 1 less than or equal to x less than or equal to 1. So, this implies, according to these ideas, the probability distribution function is minus 1 to 1 f of x dx, and then the x lies between minus 1 to 1, therefore 0 to half and half to 1, and 0 to 1, 0 to half, the corresponding value is x square, and corresponding probability continuity function we have 2x, this value you substitute here and this value substitute here, and using the integration probability density function, using the integration 2x, this integrate it, we have 2 into x square by 2 and over the limit 0 to half, and here 6 by 25 into 3x minus x square by 2 over the limit half to 1. So, we have half, and here this will be what, 3 minus 1 by 2 minus of 3 by 2 minus 1 by 4 by 2, and simplify, we have 13 by 25. So, this is the required answer for the given problem. So, if you use the property of CDF, so probability of mod x less than or equal to 1 where x lies between minus 1 to 1, So, we have f of 1 minus f of minus 1 equal to 13 by 25. Now, using the probability of PDF, so x lies between 1 by 3 to 4, and we have an integral 1 by 3 to 1 by 2 2x dx plus 1 by 2 into 3 of 6 by 25 into 3 minus x dx equal to 8 by 9. Now, using the property of CDF and probability of 1 by 3 less than or equal to x less than 4 is f of 4 minus f of 1 by 3 equal to 1 minus 1 by 9 equal to 8 by 9. So, this way we can calculate the probability of cumulative density function and probability density function. Next example, in a random variable k is uniformly distributed over 0, 5. What is the probability that the roots of the equation 4x square plus 4kx plus k plus 2 equal to 0 are real? So, in a random variable k is what? Uniformly distributed 0, 5. According to the PDF, k equal to 1 by 5 and k lies between 0 to 5. So, the rule says that probability of root of 4x square plus 4x plus k plus 2 equal to 0 are real. It means you take the discriminant of this quadratic equation is positive. So, the discriminant is k square minus k minus 2 greater than or equal to 0, and we have a factor k minus 2 into k plus 1 is positive, and we have the cases if k greater than or equal to minus 1 and k greater than or equal to 2, or k less than or equal to 2 and k less than or equal to minus 1. Therefore, probability of k greater than or equal to 2 or k less than or equal to minus 1 is probability of k greater than or equal to 2. Therefore, we have the integral 2 to 5 f of k dk equal to 1 by 5 into 5 minus 2, which is equal to 3 by 5. Next example, a point P is taken at a random on a line AB of length 2a. All the position of the point being equally likely, find the probability that the product AP into PB is greater than a square by 2. So, let AP equal to x and PB equal to 2a minus x. Since all the position of the point P are equally likely, therefore, x equal to AP is uniformly distributed over 0, 2a. Therefore, the PDF of x equal to 1 by 2a. Now, the given hypothesis AP into PB is greater than a square by 2. It means the probability of x into 2a minus x is greater than a square by 2, and if you multiply it becomes what? 2x square minus 4ax plus a square is less than 0 after simplification. Then we have to factorize. We have probability of x minus 1 minus of 1 by root 2 into a into x minus of 1 plus 1 by root 2 into a is always negative. Since the factor of the quadratic equations are 2x square minus 4ax plus a square are x minus of 1 minus 1 by root 2a and x minus of 1 plus 1 by root 2a. So, this can be written as probability of 1 minus 1 by root 2a less than x less than 1 plus 1 by root 2a. Therefore, we have the integral 1 minus 1 by root a into 1 plus 1 by root a is f of x dx, and we have a limit, upper limit minus lower limit. So, root a by 2a equal to 1 by root 2. So, this way we can calculate the problem. And next one, if the continuous random variable x represents the time of a failure of a system that has been put into the operation at t equal to 0, find the conditional density function of x. Given the system has survived up to time t and deduce the same when x follows the exponential distribution with the parameter lambda. Now, according to the conditional distribution function, f of x over x greater than t is probability of x less than or equal to x, and x greater than t is divided by probability of x greater than t. Therefore, probability of t less than x less than or equal to x divided by probability of t less than x less than infinity. So, we have f of x minus f of t by 1 minus f of t if x is greater than t, otherwise it becomes 0. For CDF, conditional density function or cumulative density function is f of x such that x greater than t is the differentiate of the given function. Therefore, d by dx of f of x over x greater than t, and this implies f of x by 1 minus f of t. For exponential distribution, we have f of x equal to lambda into e power minus lambda x, where x is positive, and f of x is when 0 less than x lambda into e power minus lambda power x dx, and integrate it, it becomes 1 minus e power minus lambda x. So, after simplifying the upper limit, lower limit and simplify, we have what? Lambda into e power minus lambda into whole power x minus t equal to f of x minus t. Now, next example, if f of t is unconditional density of the time of failure of a system, h of t is a hazard rate or conditional failure rate or conditional density of t, find f of t in terms of h of t, deduce t follows a Rayleigh distribution when h of t equal to t. So, the conditional density of t is given t is greater than t, the hazard rate is given by h of t equal to f of t by capital T of greater than t. We described these ideas as f of t by 1 minus f of t, and f of t is a differentiation function, therefore, capital F dash of t by 1 minus f of t, and taking integral on both sides of this function, so that it will be integral 0 to t h of t dt equal to integral 0 to 1 f dash of t dt divided by 1 minus f of t. Differentiate denominator, get the numerator, therefore, a negative sign, therefore, minus log of denominator, therefore, minus log of 1 minus f of t over the limit 0 to t. Upper limit apply it, it becomes 1 minus f of t, lower limit becomes 0. Therefore, the function reduces to what? F of t equal to 1 minus e power minus integral 0 to t h of t dt. So, we have small f of t h of t into e power of minus 0 to t h of t. When h of t is t, then f of t equal to t into e power minus integral 0 to t dt. So, the value of this one is what? E power minus t square by 2 into t. So, this is called as a Rayleigh distribution. Next, we have a problem. If a continuous random variable x of n of 0 comma 2, find a probability of x lies between 1 to 2 and probability of x lies between 1 to 2 by x greater than or equal to 1 based on conditional probability. Now, x follows n of 0 comma 2 means a density function, and the corresponding function is 1 by 2 into root 2 pi into e power minus x square by 2, where x lies between minus infinity to plus infinity. Now, we have a direct definition. When the x lies between 1 to 2, then we have the integral 1 to 2 f of x dx, and the values lies between in between 1 to 2 is 0.5 to 1, therefore, 0.5 to 1 phi of t dt, putting t equal to x by 2, and we have a standard normal density, and then integral 0 to 1 phi of t dt minus integral 0 to 0.5 phi of t dt. So, the value of this one is 0.3413 and the value is 0.195, and according to the table, normal distribution table, you can directly use this and then we can get the value and subtract them. We have 0.1498. So, if probability of 1 less than or equal to x less than or equal to 2 by x greater than or equal to 1 is probability of 1 less than or equal to x less than or equal to 2 and x greater than or equal to 1 divided by probability of x is greater than or equal to 1. So, for the numerator, after simplification we have probability of 1 less than or equal to x less than or equal to 2 divided by probability of 1 less than or equal to x less than infinity. So, you know the value of the numerator, substitute is 0.1498 divided by the probability of x greater than or equal to 1 is integral 0 to infinity phi of t minus integral 0 to 0.5 phi of t dt. After supplying this, we have this value. Now, we are going to discuss two-dimensional random variable. For example, 3 balls are drawn at a random without a replacement from a box containing 2 white, 3 red and 4 black balls. If x denotes the number of white balls drawn and y denotes the number of red balls drawn, find the joint probability distribution of x comma y. So, as there are only 2 white balls in the box, so x can take the values either 0, 1 and 2 and y can take the value 0, 1, 2 and 3. Now, we have a chances probability of x equal to 0 and y equal to 0. So, probability of drawing 3 balls, none of which is white or red. Probability of all 3 balls drawn is called it as black. Therefore, the rule is 4C3 by 9C3 equal to 1 by 21. If x equal to 0 and y equal to 1, then probability of drawing 1 red and 2 black balls is 3C1 into 4C2 divided by 9C3 equal to 3 by 14. Similarly, probability of x equal to 0 and y equal to 2 is 3C2 into 4C1 by 9C3 equal to 1 by 7 and probability of x equal to 0 and y equal to 3 is 1 by 84. Now, we have all the possibilities from x and y. If x0, y0 what happened, x1, y1 what happened, x2, y2 what happened, x equal to 1, y equal to 1, x equal to 1, y equal to 2, x equal to 1, y equal to 3. So, we calculated in all possibilities of x and y. Therefore, x equal to 1 and y equal to 0, so 1 by 7 will come like this and 1 1 is 2 by 7, 1 2 is 1 by 4, 1 3 is 0 since only 3 balls are drawn, 2 0 is 1 by 21, 2 1 is 1 by 28, 2 2 is 0, 2 3 is 0. Therefore, the joint probability distribution represented in the form of the table and check it out, all the sum is equal to 1. So, this is called it as joint probability distribution of x and y. Next question, find the bivariate probability distribution of x and y given below. Probability of x is greater than or equal to 1, sorry less than or equal to 1 and probability of y is less than or equal to 3, probability of x is less than or equal to 1 and y less than or equal to 3 and probability of x less than or equal to 1 by y less than or equal to 3, probability of y less than or equal to 3 by x less than or equal to 1 and probability of x plus y less than or equal to 4. So, we have x and y corresponding 1, 2, 3, 4, 5, 6 and 0, 1, 2. So, the table value is also given. So, it has no issue and directly we can solve the problem. Now, you start with probability of x is less than or equal to 1 means x equal to 0 and x equal to 1 and probability of x equal to 0 and x equal to 1 mean probability of j equal to 1 to 6 of x equal to 0 and y equal to j mean you start with j equal to 1, therefore 0 1, next 0 2, 0 3, 0 4, 0 5, 0 6. So, 0 1 from the table is 0, 02 is from the table is 0, 03 is 1 by 32, 04 is 2 by 32, 05 is 2 by 32, 06 is 3 by 32. Simply add them, and similarly probability of x equal to 1 and y equal to j is, j varies from 1 to 6, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Therefore, 1 by 16, 1 by 16, 1 by 8, 1 by 8, 1 by 8, 1 by 8. So, simply add them. We have 1 by 4 plus 5 by 8 equal to 7 by 8. And probability of x is less than or equal to 3 is equal to probability of y equal to 1 and y equal to 2, I equal to 3. Therefore, summation I equal to 0 to 2, probability of x equal to I and y equal to 1 plus summation I equal to 0 to 2, probability of x equal to I and y equal to 2 plus probability I equal to 0 to 3, 0 to 2, x equal to I and y equal to 3. So, that is the meaning of P of y equal to 1, P of y equal to 2 and P of y equal to 3. So, now let us start I equal to 0. So, what are the possibilities? 0, 1, 1, 1, 1, 2. This is the first case. Second one is 0, 2, 1, 2, 2, 2. Third case is I equal to 0 and y equal to 3, that is 0, 3, 1, 3, 2, 3. So, this value you substitute it and you have what 3 set of the values will be generated from the table, and simply take LCM and do that, we have 23 by 64. For second question, probability of x is less than or equal to 1 and y is less than or equal to 3 means probability of x equal to 0 and y equal to j, where j varies from 1 to 3, plus probability of j equal to 1 to 3, probability of x equal to 1 and y equal to j. Now, for first case, j varies from 1 to 3 is 0, 1, 0, 2, 0, 3, do that. For second case, 1, 1, 1, 2, 1, 3, do that. From the table substitute it, you get 9 by 32. When probability of x is less than or equal to 1 by y less than or equal to 3 is probability of x less than or equal to 1 and y less than or equal to 3 by probability of y less than or equal to 3, which is equal to 9 by 32 already found out, and probability of y less than or equal to 3 also found out, 33 by 64 the above. So, we have the value of 18 by 23 will come, and probability of y less than or equal to 3 by x less than or equal to 1 is probability of x less than or equal to 1 comma y less than or equal to 3 by probability of x less than or equal to 1, which is equal to 9 by 32 by 7 by 8, which is equal to 9 by 28. So, we have probability of x plus y less than or equal to 4 is the cases j varies from 1 to 4, p of x equal to 0 comma y equal to j, j 1 to 3 x equal to 1 and y equal to j, j 1 to 2 x equal to 2 to y equal to j, and it means 0, 1, 0, 2, 0, 3, 0, 4 you have to find out and add them, you get this value. Similarly, 1, 1, 1, 2, 1, 3 you have to do this, and then 2, 1, 2, 2, 2, 3 you have to do that. So, this is a way we can do with the help of joint distribution. Next example, the joint probability mass function of x comma y is given by p of x comma y is k into 2x plus 3y, where x varies from 0 to 2 and y varies from 1 to 3. Find all the marginal and conditional probability distribution. Also find the probability distribution function of x plus y. Now, we have a joint distribution, x comma y is given below. So, the relevant probability computed using the given law, where x and y, and x varies from 1 to 3 and y varies from 1 to 2, and corresponding table is, you have to check it from the given problem. See, x equal to 0 you take it and y equal to 1 you take it, and substitute in the given function. X equal to 0, y equal to 1, then probability of x comma y is k into 2x plus 3y, right. So, k into x 0, 2 into 0 plus 3 into 1, which is equal to 3k. So, that is the 3k. So, this is the technique you have to apply with the help of the given function, and x equal to 0 and y equal to 2 we have 6k, x equal to 0 and y equal to 3 we have 9k, and x equal to 1 and y equal to 1 we have 5k, and x equal to 1 and y equal to 2 we have 8k, x equal to 1 and y equal to 3 is 11k, and x equal to 2 and y equal to 1 is 7k, x equal to 2 and y equal to 2 we have 10k, and x equal to 2 and y equal to 3 is 13k. So, that we have the summation j equal to 1 to 3, summation I equal to 0 to 2, p of xi yj equal to 1. That is, the sum of all probabilities in the table is equal to 1. Therefore, 72k equal to 1, therefore, k equal to 1 by 72. So, we found out the value of k, and then we have a marginal probability distribution is I comma pj. The rule is pj is nothing but j equal to 1 to 3 summation pij. It means I equal to 0 and j varies from 1 to 3, therefore 0 1, 0 2, 0 3, and already we found what this value of P01 is 3k, where k equal to 1 by 72, and substitute. So, 0 1, 0 2, 0 3 will come, sum them, we have 18 by 72. Similarly, when I equal to 1 and j varies from 1 to 3, we have P11, P12, P13. So, we have 24 by 72, and I equal to 2 and j varies from 1 to 3 is P21, 22, 23 equal to 30 by 72. You see the sum them, the value is what, 30 plus 24 is 54, 54 plus 18 is 72, 72 by 72 is 1. So, totally 1 will come. So, this is called it as marginal probability distribution function. So, I comma pi of p over pi, where I varies from 0 to 0 1 2 is the tabular form is x equal to I and pi1 by p star of 1, which is equal to 0, and corresponding 3k by 15k equal to 1 by 5. When x equal to I equal to 1, then 5k by 15k is 1 by 3. When I equal to 2 and pi 1 of pi is 7k by 15k is 7 by 15, and we have the tabular representation of the total probability is 1. For the conditional distribution, if you take y equal to 2 and x equal to I, then rule is pi2 by p2. So, when I 0, what happened? Pi2 0 2 you take it, already know, and P2 is 24k, therefore substitute you can get it. Similarly, for 1 and 2 corresponding table we can do that. Once you understood that when y equal to 2, we can extend to y equal to 3 and x equal to I and pi3 by p3, and corresponding value is 0 corresponding 3 by 11, for 1 1 by 3 and 2 13 by 33, therefore total value is 1. So, the probability density, cumulative probability density function of y when x equal to 0 is y equal to j j is varies from 1 to 3, then we determine the corresponding P naught by P naught j, 1 by 6, 1 by 3, 1 by 2 will come. Go ahead with x equal to 1, you can get the value corresponding to j equal to 1, 2, 3, get it. When x equal to 2, j varies from 1 to 3, we have 7 by 30, 1 by 3, 13 by 30 respectively. Now, once you calculated all these CPD, then directly we can go to the probability distribution. Simply we can add x and y, so that for first case P naught of 1 is 3 by 2, 3 by 72. For second case P of 0 2 plus P 1 1, we have 11 by 72. Next is 0 3 1 2 2 1 is 24 by 72. For fourth case P 1 3 plus P 2 2 is equal to 21 by 72, and fifth case P 23 is 13 by 72. So, the cumulative value of this one is 1. Hence,